Good afternoon, my dear students. First, I welcome you my YouTube channel, AN Talukdar Maths. I hope that my Pro channel, this channel, I help you in the subject maths, and I also expect in the lockdown period you are utilizing your time in the best possible way, involving yourself in enhancing your knowledge in different subjects. Today I am going to start a new topic that is called differentiability, and this particular differentiability you get a glimpses of ideas in the class 11. So today I am going to start with the basics, and then I am moving ahead with in details of this particular subject. The name of the topic is differentiability. Is differentiability. Okay, so let us draw a graph function. From here we can start to explain this, how we get the differentiation of a particular function. Suppose that this is y equal to fx, y is a function of x, and suppose that this is a point p. This is a point pxy on the curve. Pxy is a point on the curve, and suppose there is an increment of x. This is called what? This amount is called what? Delta x. This is an increment of x, and finally this point is x plus, this point is x plus delta x, and this is final value, this is initial value, x plus delta x minus x. This distance is x, and this distance is what? X plus delta x. So x plus delta x minus x is equal to what? Delta x. And this delta x is called increment of x. Increment of x. This is x. This length is y. Okay. Since the point is xy. Now this is the x coordinate given. For corresponding y coordinate will be what? This, and I will get a point here. Suppose this is called q. So what is the coordinate of the point q? X coordinate becomes what? This distance. This distance is what? X plus delta x. This is x plus delta x. So this is y. This amount is also y. So when there is an increment of x, delta x, so increment there will be a corresponding increment of y, that is called what? Delta y. This amount is called delta y. Okay? This amount is called what? Delta y. And finally your point is x plus delta x, comma y plus delta y. Okay. Now since pxy is a point on the curve, and here y is called the image of x divided by y to the fx. So similarly, x plus delta x, y plus delta y, that is coordinate of the point q is this. Therefore, we can say that since this is the graph of q is a point on the point of the curve y, so here we can get y plus delta y can be written as what? F of x plus delta x. Okay. So there is an increment of x is what? Delta x, and corresponding increment of y is what? Delta y. So finally your function is y equal to fx. So we can write y plus delta y equal to what? F of x plus delta x. Okay. Therefore, what will be delta y? What will be delta y? Delta y equal to y plus delta y minus y. Okay. Y plus delta y can be written as f of x plus delta x, and y is written as fx. So delta y is equal to this. Now dividing both sides by a quantity delta x, you will get f of x plus delta x minus fx divided by what? Delta x. Okay. This quantity is called increment ratio, which is a ratio. Okay. What ratio? Ratio of increment of y with respect to the increment of x. this particular quantity del y by del x is called the increment of ratio of increment of y with respect to the increment of x. Okay, I think you understand this part. From the graph it is clear this particular quantity is called ratio of increment of y with respect to the increment of x. Now if we take the limiting value of this particular ratio as delta x tends to 0, both sides, if I take a limiting value delta x tends to 0, del y by del x equal to limit delta x tends to 0, right hand side will be f of x plus delta x minus fx divided by delta x. This is the limiting value of this particular quantity, ratio of increment of y with respect to x. And this particular limiting value is denoted by a particular symbol which is called dy by dx or f dash. Both are same, and this is called differential coefficient. Name is what? Differential coefficient. Differential coefficient. Okay, and also called derivative of y with respect to x, or derivative of fx with respect to what? X. That means f dash x or dy by dx is defined as limit delta x tends to 0, f of x plus delta x minus fx divided by what? Delta x. Now, as usually, delta x is denoted by a symbol small h, and finally you get dy by dx or f dash x equal to limit h tends to 0, f of x plus h minus fx divided by h. Okay, this is called the derivative of a function fx from the first principle. That means the initial derivative, the initial definition of a function, how to find the derivative of a particular function y equal to fx. This is called the derivative of a function from the first principle. Okay, this particular concept I got in first year. I just give an idea. Now I am moving ahead with a special concept, that is what actually dy by dx is, physically what actually it means, geometrically what actually it means, f or dy by dx. I am going to explain, and then you can get an idea. So why dy by dx or f is required? What is its application? Okay. Now go to the again graph of the function. Go to the graph of the function. You see your dy by dx or f dash x is what? Limit h tends to 0, f of x plus hx plus h x plus delta. F of x plus delta x minus fx divided by what? Delta x. Okay, this is we already got, that is differential coefficient or dy by dx, or it is called derivative of a function with respect to x. What is this geometrical unit? Now comes to the graph again. Again to the graph, you see these are 2 points in a curve. So you join these 2 points, and this particular line is known as secant. It is known as secant of the graph. Okay, and this secant of the graph makes an angle, suppose phi, with positive direction of x-axis. Therefore, the slope of PQ will be tan phi. Slope of PQ will be tan phi. If this angle is phi, then that angle is also phi. This amount is delta x, this is delta x, so this is delta x and this is delta y. Therefore, tan phi equal to what? Del y by del x. From the graph is clear that tan phi equal to what? Del y by del x. That means ratio of increment of y with increment of x represent the slope of the secant joining these two points. Slope of the secant joining these two points. Now, if you see, if q approaches to p, q tends to p. अगर मैं q को इधर ले आ रहा हूँ पॉइंट में, ग्राफ में इधर ले आ रहा हूँ, इधर, then what happens? This line will be rotated in this way, okay? And finally, what will happen? This particular secant becomes a tangent to the star at this point. Q tends to p. Q over p same हो जाए तो क्या होगा? Okay, this will be happen. Okay, ultimately you get a tangent. Okay, ultimately you get a tangent at the point P, and suppose the tangent makes an angle theta with the positive direction of x-axis, and therefore tan theta is the slope of the tangent. We know that from the definition of slope, if a line makes an angle theta with the positive direction of x-axis, then tan theta is called slope. Therefore, slope of the tangent will be what? Tan theta. When what happens? Q tends to p, then phi is this angle phi what? Q tends to p. The Q point tends to p implies the angle phi tends to what? Theta. Angle phi tends to theta. Okay. That means secant becomes tangent. That means what happens? If you take tan phi, change to what? Tan theta. That means when this secant becomes the tangent, then what happens? Slope of the secant becomes slope of the tangent. Okay? I think you understand. Now comes to our how to relate dy by dx. Now see from the graph. Here it's very important. Q changes to P. Q changes to P means what? Q को क्या कर रहा हूँ मैं? ग्राफ से इधर ले आ रहा हूँ. जितना ग्राफ इधर है, सपोज Q इधर आ गया तो क्या हो गया? डेल्टा x रिड्यूस हो रहा है. सिमिलरली डेल्टा y रिड्यूस हो रहा है. If Q अगर इधर आ जाए तो फिर देखो डेल्टा x कम हो रहा है. फिर Q इधर आ रहा है तो डेल्टा x कम हो रहा है. Then in the way what happen? When Q approaches to P, then delta x is reducing. Delta x is reducing. And when Q is approximately is equal to P, then delta is approximately is equal to what? 0. That means Q tends to P implies delta x tends to 0. Okay? Understood? So here you see what we get? Del y by del x equal to what? Tan phi from this relation. Okay, from this relation. Now taking limiting value, limit delta x tends to 0, del y by del x equal to, when you takes delta x tends to 0, what happens? Q tends to p, and Q tends to p means tan phi tends to what? Tan theta. So if tan phi becomes what? Tan theta. I think you understand. You see, when you take delta x tends to 0, limiting value, at that time Q tends to what? P, and Q tends to P means phi tends to theta, and that means tan phi tends to what? Tan theta, which means this is nothing but our what? Dy by dx. This is what? Dy by dx. And tan theta is what? Slope of the tangent. That means dy by dx for f dash x. What we get finally, the conclusion. Final conclusion is that dy by dx or f dash x is nothing but slope of the tangent at the point what? x1. slope of the tangent at the point what? xy. This is your graph. Suppose this is the function. Suppose a point is P, xy. Then if you draw it and you get a tangent at this point, then slope of the tangent, that is theta, then slope of the tangent representing what? dy by dx. Slope of the tangent representing what? dy by dx. That means tangent makes an angle theta with the positive direction of that tan theta is equal to what? dy by dx. Okay. Finally, what you get? dy by dx or f dash x representing what? Slope of the tangent to the curve at the point what? P x y. What? P is any point. And if P is a particular point, suppose this is the graph. Suppose x1, y1 is a particular point on the graph. Okay. Then dy by dx at x1, y1 representing what? Slope of the tangent. Slope of the tangent. Slope of the tangent to the curve at x1. Okay. Here x1. What is x1? x1 is a point in the domain of the function. This is x1. Okay. x1 is a point in the domain of the function. Okay. Understood? So finally, what we get? That is dy by dx or f dash x representing the slope of the tangent to the curve y equal to fx at any point xy. If the point is particular x1, y1, then slope of the tangent is denoted by dy by dx at x1, y1. Or you can say f dash x is again f dash x1. F dash x1 representing slope of the tangent to the curve at x1, y1. Okay. Or you can say that f dash x1 representing the slope of the tangent at the point x1 in the domain of the definition. The domain of the definition. Domain के अंदर x1 एक point है, उस point में f dash x1 का मतलब है slope of the tangent at that point x1. Okay. If a belongs to df, domain of the function, then f dash a representing what? Slope of the tangent. That actually, and this slope of the tangent is a real number. Slope of the tangent is a real. That means f dash a is some real number. Okay, it is some real number, and which is the slope of the tangent. And we know that in a particular point in a graph, so you draw the graph. Suppose this is a point, you can draw only one tangent. That means tangent is also unique. That means what happens? F dash x must have a unique value. That means f dash a will be exist when it is finite and fixed. When it is finite and fixed. F dash a will be exist when it is finite and fixed. F dash a means slope of the tangent, and since tangent is unique, so value of f dash a must be unique. Okay. Again, you see, suppose that I am drawing another graph, and from here it will be more clear. Suppose that this is the closed interval AB. Function is defined in closed interval. Suppose this is the function. Okay. This is the function y equal to fx. Okay. Other than a and b, you see, if you draw tangent, you will get only unique tangent. In every point, you will get tangents. You will get tangent. But at the end point, you see, you can this point. What happens at the point x is equal to a? What will happen? The graph, the tangent is this is the tangent, this is the tangent, this is the tangent. That means you are getting many tangents. Ultimately, what will happen? F dash a at that point. F dash a at that point does not exist. Why does not exist? Because it is not unique. But in other point, if you consider this point or this point or this point or every point, there is a one tangent. There is a one tangent. Similarly, in this point, you see this is a tangent, this is a tangent, this is a tangent. Many tangents you can draw. Okay, and therefore, in this closed interval, if function is defined in a closed interval AB, then f is not continuous and not differentiable. F is not differentiable at x is equal to what? At x is equal to what? A and B. End point में क्या होता है? Differentiable नहीं होगा. That means it will be differentiable. It will be differentiable in the open interval B. In the open interval B. So the f dash x or dy by dx is nothing but slope of the tangent to the curve at any point. If the point is particular, then on that particular point you get one tangent, and tangent is unique. Therefore, f dash a is a finite and a fixed value. It's also unique. Okay. I hope that you understand what actually dy by dx or f dash is. What is the definition of dy by dx or f dash x, and what is its mathematical meaning? I try to explain, and I hope you understand. You go through these videos repeatedly and note down all the important points, and in the next class I will discuss about the existence of derivative, and also I will discuss a very important theorem which is called, if a function is differentiable at a point, then it is automatically continuous. But if the function is continuous at a particular point, it may not be differentiable. This is very important theorem I will discuss. Hope that you all understand, and whenever you watch the video, never watch one time, watch 1, 2, 3, 4, 5 times and try to understand, relate your text, and put down all the important points. Thank you very much for listening me and watching my videos. Thank you.